All right, so let's go ahead and get started on P-3, Chapter P, Section 3, and we're talking about radicals and rational exponents. Now, you'll notice that this section and several of the sections in this chapter are very short, and again, that's because all of this information is stuff that you should know coming into pre-calculus. So we're going to just be going over it really briefly, but if you have questions, please come and talk to me and ask for help. A radical expression, we have some kind of radical here. This n can be any integer, so it could be a square root, cube root, fourth root, and so on. Now the rules for square roots is if I have an even power in here and an even index, then what I have here needs to go in absolute value. I also can separate what I'm taking the radical of, whether it's multiplication or division. Now, like radicals are radicals with the exact same index and exact same radicand. This might be a term that you don't recognize. This a value here, whatever is underneath the square root, that is our radicand. Okay. Now, this radical sign here, the actual square root itself, or whatever kind of root, that's the radical sign. And this n right here is our index. Okay. Now the whole thing gives us a radical expression. Okay. So when we're talking about like radicals, the index and the radicand need to be exactly the same for them to be like radicals. Rationalizing the denominator, that's a phrase that you've heard since Algebra 1, but oftentimes students forget what it means. It means that we want to get the radical out of the denominator. So we can multiply the top and bottom by the conjugate of the bottom. Conjugate is another term that sometimes students will forget. If I have 2 plus square root 3, the conjugate of that would be 2 minus square root 3. The only thing that changes is the sign in the middle. Sometimes we can multiply by a smaller factor or something else, and that can also rationalize the denominator, but generally we're going to need to use the conjugate. We have other kinds of roots, the nth root, so generally we can talk about this as the nth root, and this would be an exponential form here. Now if n is even and b is greater than 0, we can take the radical that way. But if we're looking at an odd index, so like 3, 5, 7, and so on, b can be any real number. So it can be something negative. We can take the cube root of a negative number. All right, now if the index and the exponent are the same here, then if n is odd, meaning our index is odd, then we end up with just a. But again, if n is even, we have to put this into absolute value. The reason for the absolute value is that we know we can't take the even root of a negative number, so the a value must be positive. Now, product and quotient rules also work the same as square roots for any root, cube roots, fourth roots, and so on. So if we have a product here, we can separate it. If we have a quotient, we can separate it. Now, rational exponents are really just fractions in the exponent. So this would be a to the power of m over n. And if I have the nth root of a, it represents a real number where m over n is a positive rational number and n is greater than 2, then we can rewrite this in a couple different ways. So if I have a to the power of m over n, then that's equal to the nth root of a to the power of m. And this power of m in here, it can either be inside the radical or you can put it on the outside after you take the root. Okay? All right, and that will be the end of section 3 for us.